Good morning, student. In last period, we discussed about atomic number, atomic mass number. Also, we have to discuss about the distribution of electrons in a different shape. We know that different scientists classify or discover the structure of an atom. Inside the atom, in this topic, we have to learn the J.J. Thomson atomic model. Next, Rutherford atomic model. Next, we have to study the Niels Bohr atomic theory or Niels Bohr atomic model. We know that all these scientists discovered that an atom is a minute particles which is made up of three fundamental particles. These three fundamental particles are as protons, electrons and neutrons. An atom consists of these three particles. Protons having a positive charge. Protons are denoted by letter P. Then electrons are negatively charged particles. Electrons are denoted by letter E. And neutron are chargeless. So in any atom, these three fundamental particles are present. In an atom, the nucleus, protons and neutrons are present. Protons and neutrons are present in the nucleus, and electrons are revolve around the nucleus. So electron having negative charge, protons having positive charge, and neutron has a no charge. It is a chargeless. Then also we have to discuss about or learn about atomic number and atomic mass number. Look at this. Atomic number denoted by letter Z. Atomic number means the number of proton or neutron in the number of protons is called as the atomic number, denoted by letter Z. Then atomic mass number, the sum of a proton and neutron in an atom is called as the atomic mass number. Atomic mass number is denoted by letter A. Look at this. Atomic mass number denoted by A. A equal to P plus N. Means the sum of a proton and neutron in an atom is called as an atomic mass number. Then also we have to discuss or learn that distribution of electrons in an shell or in an atom. The atom consists of four different shells in which the electrons are revolved. We have to study the number of shells as a K, L, M and N. These are the shells in which all the electrons revolve around the nucleus, and the capacity of electrons are different in a different shell. Look at this. In atom, the nucleus is the center part. So the closest shell or closest orbit of the nucleus is a K shell. K shell consists of only 2 electrons. The capacity of a K shell is 2 electrons. L shell having the capacity of electrons 8. M shell consists of 18 and L shell consists of 32 electrons. So these are the capacity of electrons which are present in each shell. The minimum electrons are present in a K shell and the maximum electrons are present in a N shell. So with the help of these electrons, we have to study electronic configuration of element. Electronic configuration of elements are determined by using atomic number. Look at this. Today we know that 118 elements were discovered. All these elements are placed with the help of atomic number, with the help of electronic configuration. So electronic configuration is find with the help of atomic number. Also we have to learn in last period. Also we discuss about the valency. Valency means number of electrons which are present in a outermost orbit is called as valence electrons. And the atom which complete the 8 electrons in their outermost orbit, how many electrons are required to complete 8 electrons? 8 electrons or number of electrons to complete the 8 electrons in outermost orbit. This number is known as a valency. So most of the metals lose the electron and non-metal accept the electron. Also we have to discuss about. So in this period we are going to discuss about isotope. Look at this. Isotopes are based on atomic number and atomic mass number. Look at this. Atomic number means the number of a proton. The number of a proton in an atom is called as a atomic number. It is denoted by letter Z. Atomic mass number denoted by letter A. Atomic mass number is the sum of a proton and neutron in an atom. Atomic mass number means the sum of a proton and neutron in an atom is called as an atomic mass number. So first we have to discuss about what is the isotope. How we have to calculate the isotope. Dear student, isotope of an element is determined or is discovered with help of atomic number and atomic mass number. So first we have to take the information about isotope. Isotope means the elements having same atomic number but different atomic mass number. Such elements are called as isotope. Look at this. Some elements having same atomic number but different atomic mass number is called as isotope. Look at this. Some examples we have to take. Carbon having a two isotope C612 and C614. Look at this. Carbon is an element having same atomic number but different atomic mass number. So carbon has a two isotope C612, C614. In this example, carbon having the same atomic number 6. 6 is the same atomic number and different atomic mass number is 12 and 14. Another example we have to take chlorine. Chlorine is Cl1735, Cl1737. In this example, chlorine having same atomic number 17 and atomic mass number is different 35, 37. So chlorine has a two isotope Cl1735, Cl1737. Third example, hydrogen. Hydrogen has a three isotope H1. Atomic number of hydrogen is 1. H11, H12 and H13. Look at this. In a hydrogen, same atomic number but different atomic mass number. Atomic mass number is the same, 1. 1 is atomic number is the same but different atomic mass number 1, 2, 3. These are the different atomic mass number of a hydrogen. So an isotope means the element having same atomic number but different atomic mass number is called as an isotope. We have to write here, look at this symbol. Isotope we have to write. Isotope means same atomic number but different atomic mass number. Atomic mass number denoted by Z. Atomic mass number denoted by A and atomic number denoted by Z. Element having same atomic number but different atomic mass number is called as an isotope. So we have to take three examples. Carbon has a two isotope in which 6 is the atomic number which is the same but atomic mass number is a different 12 and 14. So carbon has a two isotope C612, C614. Another example, chlorine. Chlorine has a two isotope in which atomic number is the same, 17 is the same. Chlorine atomic number is the 17 but atomic mass number is a different 35, 37. So chlorine has a two isotope. Next, hydrogen. hydrogen has a 3 isotope, H11, H12, H13. Hydrogen, deuterium and tritium. Hydrogen has a 3 isotope. So these are the some examples based on isotope. So from this example we conclude that isotope means the elements having the same atomic number but different atomic mass number is called as an isotope. Now we have to discuss about the uses of isotope. Look at this. It is clear that it is understand easily. The elements having same atomic number but different atomic mass number is called as an isotope. Carbon has a 2 isotope, chlorine has a 2 isotope, hydrogen has a 3 isotope. In all these 3 examples, atomic number is the same. Carbon 6, atomic number same, atomic mass number different. Chlorine, atomic number same 17, but atomic mass number is different. Hydrogen, atomic number same 111, but atomic mass number is different 1 2 3. So these are the some examples of isotope. Now we have to learn the next point, that is uses of isotope. Look at this. Uses of isotope. Uses of isotope. Look at this. Uranium 235. First, uranium 235 is isotope of element which is used for production of electricity in a nuclear reactor or in a nuclear project. Uranium 235 is element, the isotope of uranium 235, which is important for production of electricity. Iodine, cobalt are also used for diagnosis and treatment of cancer. Iodine is used to treatment of goiter disease. We have to given some uses in our textbook. Look at this. Uses of isotope. On page number 37, we have to given 6 uses of isotope. The first use of isotope is as uranium 235. Uranium 235, which is used for the production of electricity in a nuclear project or nuclear reactor. Second, cobalt 60. Look at this. Cobalt 60 are used in the treatment of disease like cancer. Cobalt 60 is used for the treatment of cancer. Next, number third, iodine 131 is used in the treatment of goiter disease. Goiter disease or in the treatment of a thyroid gland which is present in our throat. To control the thyroid gland, we have to use iodine 131. We have to use the iodine salt to prevent any disease of a thyroid gland. Number 4, the radioactive isotopes are used in the detection of cracks, leakage in the underground pipes. Sodium 24. Sodium 24 is used to find the leakage of pipes underground. And number 5, the radioactive isotope C14 is used in determining the age of archaeological objects. Archaeological objects for finding the ancient object which are present inside the earth. We have to find the age of this object with help of C14. C12 and C14. Look at this. C12 and C14. These are the carbon substances which are present in a human body. We have to determine the age of death bodies of animals or human being can be calculated with the help of C14. Carbon 14, which is a substance, which is a element which are present in a human body animals for finding the age, determination of age after the death, how many years, how many days are passed the animals or human beings which are buried into the ground or which are buried into the soil. With help of a sheet 14, we have to determine the age of these animals or human being. So these are the some uses of isotope. Dear student, first we have to understand the meaning of isotope. Isotope means the elements having same atomic number but different atomic mass number is called as isotope. Some examples are given. Uranium 235. Uranium 235 is used for production of electricity in nuclear reactor. Cobalt 60 is used in the treatment of cancer. Iodine 131, which is used in the treatment of goiter or thyroid gland. Sodium 24 is used for determine the leakage of underground pipes. Carbon 14 and carbon 12, which is present in a human body, determine the age after the death of animals and plants, animals and human beings. So these are some uses of isotope. Now we have to discuss about nuclear reactor. We know that electricity is important for a human being. Electricity is generated with help of water, with help of wind. Also, the another way to find or to produce in a large amount with help of a nuclear reactor. Most of the countries in the world use the nuclear reactor project for the production of electricity. Look at this. In nuclear reactor, uranium 235 is element is used for the production of electricity. On uranium 235, electrons are bombarded and electric current is produces. So we have to discuss about the nuclear reactor. Look at this. This is the diagram of a nuclear reactor. In the diagram, the nuclear the electricity is produces when the uranium the electrons are bombarded. Look at this. Neutrons are bombarded on uranium to produce a large amount of electric current. So in our India, most of the in 4 or 5 places nuclear reactor project we have to be placed. With help of a nuclear projector or nuclear reactor, we have to produce a large amount of electricity. There is a harmful. This nuclear reactor is a harmful, but which is a very useful for production of electricity. And there is a chemical reaction in which uranium, the neutrons are bombarded on uranium and neutron. There is a chemical reactions and there is a nuclear chain. Nuclear chain is possible in a uranium and neutron. Neutron is bombarded on uranium and produces a large amount of electric current. So it is about a nuclear reactor. In nuclear reactor, moderator and controller we have to given. This is a uranium 235 disintegration. On uranium 235, neutrons are bombarded to produce a large amount of electricity. So in this way we have to complete topic number 5 inside the atom.